Hey there everyone, let's check out this example together. In this example, we have a magnetic field coming from left to right, and this magnetic field is equal to 0.26 Tesla, and it's hitting this 5-side shape. So I'm going to call this axis the Y, and I'm going to call this axis Z, and I'm going to call this axis here coming there is X, okay? So the magnetic field is coming this way. We have 5 different surfaces for this shape. As you see, the magnetic field is coming parallel to the Y direction. So it's coming like that, okay? And this surface is sitting exactly on the Y dimension. As you can see, this is the Y. So this surface is sitting on the Y direction and it's going up to the Z. That's it. So this surface is also all in the YZ plane. Okay, so it's parallel to the magnetic field. Okay, if it's parallel, the surface itself is parallel. So what the direction of this surface is going this way, normal. So basically, the magnetic field B makes an angle 90 degrees with this surface. So theta is equal to 90, and we know that the magnetic flux is equal to BA cosine theta, where theta is 90 degrees, cosine 90 is 0. So basically this one contributes nothing to the magnetic flux, this surface. The same for this surface too, because it's parallel to this one, okay? So also this surface contributes nothing, so that's 0. All right. So and let's look at this surface here. Okay. This surface is sitting in the XY plane, so the magnetic field passes by it, and basically because it's sitting on the surface and the magnetic field goes by it, it doesn't basically see it at all. All right, and let's see where is the direction of this one? Up. So the normal force is up. Okay, so the normal force is up here, and the magnetic field is here 90 degrees. Again, cosine 90 is 0. So this surface, and this surface do not contribute at all. Now this one is facing backwards. This is the Y is going to the back of the Y direction, just straight like this, back. Okay, so the angle is either 0 or 180. Cosine 0 is 1. So for this surface, phi B is equal to BA cosine, let's say 0 for the magnitude. Okay, so that's 1. Now B is equal to 0.26, and A, where is A for this one? The A for this one, let me just get another color. So this is A that we need to find. So 1.2 times 0.3. 1.2 times 0.3. And if you do this calculation, you are going to get, for the magnetic field, magnetic field flux 0.36 Weber. Now the remaining surface is this one. That's the remaining surface. Okay, and this surface has a dimension 0.5 times 1.2, so we can find the area, but we need to find this angle here, theta. Now how do we do that? Well, we can say tan theta, because that's theta, is equal to 3 over 4, which means that theta is equal to tan inverse of 3 over 4. And if we do this calculation, we find theta is equal to 36.9 degrees. If that angle is 36.9 degrees, okay, which means the rest of it here is 53, here, this angle, 53.1 degrees. Okay, if this angle is if this angle is 36.9 degrees, okay, so this surface makes 36.9 degrees like this, and the magnetic field is going this way, so what's left is the angle is 90 minus 36.9 degrees, which is 53.1. So now we have the angle, we have B, and we have, so B is 0.26, area is equal to 0.5 times 1.2, 0.5 times 1.2, and now the angle is times cosine 53.1, and if you do this calculation, you're going to get the same number, 0.936 Weber. And that makes sense because what goes in as a flux must go out. And that's it for this problem. Thank you.